whereas it takes 5 years for industry for medicine to reach clinical trials.
We're going to talk about how we can not just live longer, but better quality lives, and how we can use technology in order to accomplish this. Now, aging isn't officially recognized as a disease in the field of medicine, as you all know. And this has significant implications for both research and the allocation of resources. So Sadia, tell us more about that and how we can restructure the healthcare system to make it more longevity focused.
Hi. It's actually funny that in a rapidly aging world, the definition of aging is something which is still being debated by the big institutions. So while WHO a few years back did issue an ICD code which recognized aging as a disease, FDA still thinks that it is, a natural and a universal process, not a disease, and therefore not a target for drug treatment. Having said that, in the last few years, a lot of money and a lot of attention has been pouring into the research for longevity-related drugs. Is it enough to entice the pharma company to start making treatments and drugs for anti-aging? Probably not. Maybe Alex can talk more to that. But, however we define aging, the fact remains that by 2050, more than 22% of the world population will be 60 years or older. And this is up from 12% in 2015. So this kind of, paradigm shift in the composition of the population worldwide is a huge problem or a huge challenge for the governments to contend with. When it comes to healthcare, while we cannot wait for a miracle drug to appear on the market, what we have to do is to sharply change our focus to promote healthy aging. And that really means a mindset change from reactive medication to proactive and preventive healthcare, from disease-oriented healthcare systems to holistic healthcare systems, and major restructuring of the reimbursement models so that they incentivize the right behaviors, and they also promote outcome-oriented benefits, right? Instead of the fee-for-service models that we currently see in the industry. It also means that we will have to enable our community and social development sector in a way that they provide the right motivation for healthy aging. So there is no silver bullet, there's no simple answer. This is something for which the government, healthcare providers, academia, research, pharma, everybody will have to work together to reimagine a healthcare system of the future.
So a huge portion of the world population will soon be senior citizens, and this makes it all the more urgent and pressing. And Dimitri, technology has undoubtedly helped advance innovation in longevity, and this is really your line of expertise. Dimitri leads his consortium's investment arms focused on both deep tech and longevity. So tell us, Dimitri, about the aging-related challenges that have really been addressed by technology in recent years.
Yes, within our consortium, we have many companies, but the first one, Aging Analytics Agency, was established 10 years ago. And what we saw during these 10 years, the transition from understanding of the challenges towards more practical, more tangible, very clear to practice aging research, but at the same time also practical clinical applications. And I can talk, for hours what's actually good progress, good practical applications which are happened or happening right now. It is like hundreds of them, like hundreds of domains. Just briefly to mention, probably it's geroprotectors, synergetics, it's regenerative medicine, stem cells, some applications of gene therapies. Among all those hundreds of these domains, mostly I'm personally and our company is interested in rejuvenation of mitochondria research. As you know, mitochondria is the core part of the cell, but at the same time it's the core part of aging process. And there's quite substantial progress has been made over the last years on this particular matter. On the other hand, one unified technology, which is is underlying basis for all aging research and for all longevity medicine applications, it's biomarkers of aging and longevity, and in particular, applications of artificial intelligence for these biomarkers. Because whatever you are doing in science or medicine, you need to somehow to measure the efficiency what you're doing, like whether these technologies are working or maybe they are providing actually a negative effect. Now, just during this year, a lot of progress have happened with ChatGPT, with Google Health, so those general AI, strong artificial intelligence system can provide, analytics similar to human doctors. However, I don't think that AI system will replace human doctors, so it will be not AI, it will be AI in the form of augmented intelligence, when human doctors will be augmented by strong artificial intelligence systems. Today, Pure Health presents their mobile app application driven by AI. So this is one of the best visible and evident example. On the other hand, there are also quite strong progress in strong artificial intelligence narrow focused on aging research, on so-called aging clocks. Here's a company present also on this panel in Silicon Medicine. So they had the strongest artificial intelligence system for drug discovery, but at the same time, for many years, they were developing aging.ai system for narrow focused aging biomarkers. Alex probably can tell some more on this matter.
Yes, I mean, Dr. Alipur actually applies AI to drug discovery and manages 100 engineers who are working on new drug discoveries with the help of AI. Tell us a little bit more about how exactly you're using AI to accelerate drug discovery, and what opportunities and what challenges come with this approach.
Sure. So currently it takes over 10 years and over $2 billion to develop one molecule, to develop one medicine, for medicine to reach the patients, right? So if you take big pharma, top 20 big pharma, it takes them over $6 billion to develop one therapeutic. So it's unacceptably low productivity. What we're seeing right now, extremely high failure rates, and we must do something about it because there are like over 8,000 of diseases without a treatment option out there. Many of those diseases are aging-related. So aging is an underlying cause of many of those conditions. So what we do at Insilico is we use generative AI to discover novel mechanisms and novel molecules to tackle those fundamental biological processes to reverse the course or alleviate some symptoms of the disease, right? So we have treatment options for that. We have developed our platform, which is a generative AI platform, to do that automatically, whereas it takes 5 years for industry for medicine to reach clinical trials. We did it 3 times faster with our platform. So we kind of demonstrated tangibly what we can move faster and we can develop more medicines cheaper and quickly. So that's one thing. Second thing, kind of tying it up to the longevity topic, right? So as I mentioned, most of the diseases are aging related, and as Adya mentioned, the population is aging rapidly, so we'll have more and more incidence of those indications. So we must develop therapeutics which would be targeting those aging-related disorders, and additionally also targeting the underlying aging process. Currently, there is no regulatory track to address aging as a disease, right? So there is no ICD code for aging. But if we can develop therapeutics which tackles age-related disorder, we can potentially repurpose a therapeutic in the future for aging. And by that time, hopefully we'll have the right framework, the right biomarkers in place that will enable the regulatory approval. So I like to think of it, if a standard physician can save thousands of life years for patients, either surgeons or other physicians. If we develop a molecule that can add 1 life year to each human, we would become adjusted life year billionaires, so to speak, right? So it's really remarkable what we can do to accelerate that process and bridge the gap between the health span and lifespan.
Absolutely, it is remarkable. And you mentioned 10 years to develop one molecule without the use of AI. How much time does it take to develop a molecule with the help of AI?
So we have case studies where we, from zero to human clinical trials, it took us about 18 months to preclinical trials. And this is the first program we have in our pipeline focused on lung fibrosis. We have other cases for oncology indications where we did it in a year, in 1 year. Overall, we have 30 programs in our pipeline, and we're expanding into more diseases.
Incredible. It really expedites the process. Dr. Ram, how can we integrate these advances in technology and drug discovery into clinical practice?
Thank you. If you look at artificial intelligence as we understand, you have one subset which is big data, which is processed with machine learning algorithms. And then you have the technology piece. And then you have the combination of the power of this data and the technology which is integrated into clinical medicine. And if you look at clinical medicine, it's the spectrum of you go from prediction to diagnosis to therapeutics to prognostics. And if you look at AI and technology in the current day and age, it has contributed significantly to all these. If you look at prediction, I think there are models which are being built particularly for cardiovascular disease and cancers. We call it risk stratification because the fact remains that despite all advances, you get about 18 million cases of cancer a year. 10 million still die. So there is some work which has to be done, and there is a huge amount of data. If you look at cardiovascular disease, we are using AI models to predict who will get a heart attack and who will die from a heart attack, because I am by training in the cardiovascular specialties, but the answer is we have a set of indicators, but we still do not know. And this is where predictive analytics with AI-based algorithms is going to help. If you look at diagnosis, we are all aware that you have islands of expertise in complex diagnosis. But then, as they were saying, you have to democratize this expertise, and how do you do it? You cannot get these highly trained physicians to every corner. And this is where AI models are helping, particularly in mass breast cancer screening programs, colon cancer screening programs, where the AI models can do a lot of the groundwork, and then the expertise can come at the end of the spectrum and pitch in with the diagnosis. And people ask about accuracy. There have been double-blind trials where skin cancer or diabetic retinopathy, macular degeneration, AI models have been compared to board-certified dermatologists and ophthalmologists, and they have the same or a higher specificity and sensitivity in diagnosis. Does that mean it will take the role of the physician? No. It is, as Shaista said, artificial intelligence becomes super intelligence, because these trials were conducted in highly advanced university teaching centers. But you want to get this level of expertise to all corners, to all people. So that's in the diagnostic. Therapeutics, of course, we had people speaking about genome sequencing, genetic profiling. Well, some of the most recent developments, besides personalized medicine and getting targeted chemotherapy, one of the path-breaking advances is, in my time, you had to look for a human organ donor for a heart transplant. Just 2 months ago, we have reports of animal organs being used for transplants, and this is because through CRISPR technology, they were able to modify 10 specific genetic points. If you transplanted an animal organ into a human in the past, it would be rejected probably in 1 hour. These organs lasted 2 hours. So we're on the way there. If you look at AI in nanotechnology, as he was talking about drug discovery, we have found innovative means clinically, which is being applied today in breast cancer, of delivering targeted molecules which can be packaged in liposomes, where it goes and targets the specific cell, because finally it's the cellular basis of disease. Besides this, you have nanotechnology, which is futuristic, where 1959, Richard Feynman said you will have molecular machines, because the basis of disease is essentially molecular. So if you can go down to the molecule and fix the problem, you will never see the problem, because you've understood it. And people thought this is science fiction, and this has not entered the realm of clinical medicine yet, but it will soon enter that area where these micro-robots will go fixing. You have robotics, you have brain-computer interface where brain signals are being transmitted in stroke patients and in certain other categories of neurology patients, where essentially your thoughts are converted into motion, not through the normal pathway, but through brain-computer interfaces. So there is so much happening, and I myself was surprised. Our apex journal is the New England Journal of Medicine, where anything advanced comes there. And just 2 months ago, they said they are going to launch a New England Journal of Medicine AI. This is the level of advances which are taking place and clinical applications.
Absolutely fascinating. AI can be applied to every disease, every treatment, in every country eventually. And as you said, at some point we may be half human, partially robots, once they infiltrate every microorganism in our bodies. Sadia, another way to optimize resource allocation and improve patient care is harnessing big data to improve patient outcomes. Tell us a little bit about how this works.
Thank you, Dr. Ram, on touching upon how data and AI can be used to just change the face of how healthcare is delivered. So just on a system level, I just want to throw some statistics. Today, 30% of the data that is generated on a daily basis is related to healthcare. And this number, or the rate of growth of this data is about 36% as CAGR, right? There's another statistic which says that by 2030, there will be a dearth of 10 million physicians worldwide. If you look at the statistics, you see the asymmetry in the system, right? Because generally, healthcare is considered to be at least a decade behind when it comes to its maturity in terms of leveraging the data that is available to it, right? So basically, if it were up to me, I would declare an emergency on the healthcare system to accelerate their maturity of adoption and leveraging the data that's available to them. To me, there is no one application or one way in which data can help the healthcare sector. I think this is a tide that lifts all boats. But if I were to divide it broadly into 4 segments, those would be population health, supported by predictive analytics, risk stratification, resource allocation, and disease surveillance. The second would be personalized health, and Dr. Ram spoke at length about it. The third would be acceleration in the drug discovery process, and the fourth would be clinical decision support systems.
Now, Dr. Alipur has put an AI-designed drug into human clinical trials, a completely AI-designed drug. Tell us what new technologies you expect to emerge in the near future, taking this into consideration.
Oh, there are plenty of technologies out there that have shown great promise. One technology I would highlight, what Dr. Ram mentioned, robotics, is something which has come into every industry. It's something so inevitable that everybody must have a robotic strategy. At Insilico, we've built a fully automated robotics lab like in Suzhou in China. No humans allowed in the lab, 800 square meters of lab space, and it kind of features the vision of personalized drug discovery, the future where you can like take any patient and a sample from this patient, and like Dr. Fatima told previously, create an iPSC model for any disease for this patient and test it in the full automated way in robotics lab and connect it to AI platform which will design molecules or device molecule treatment for a specific individual. So that's the future that I think is coming, and personalized drug discovery, personalized medicine is something that ought to be happening. Also, regenerative medicine is another trend. I think we will see tremendous breakthroughs in regenerative medicine, organoids, creating artificial organs, new methods for preserving those organs for a longer time. So yeah, I would think these are a few areas of high promise.
So extension of what Dr. Ram was discussing earlier. And Dr. Ram and Dimitri, I'd like to put this question to both of you about the role of government and regulatory bodies in incentivizing longevity research. What do you think their role is, and where does the UAE stand in this regard?
So there's many initiatives in various countries on, something what could be named national industrial strategies on health longevity. Some of those elements potentially can be considered by UAE to be, kind of also implemented here. One example, 4 years ago, we were behind establishment of initiative on establishment of all parts parliamentary group on longevity in the UK Parliament. On the other hand, UAE, Abu Dhabi in particular, already have very sophisticated governance framework on health tech matters. In particular, during the time of pandemics, Abu Dhabi was one of the most efficient to tackle down the neutralized pandemics. And at the same time, it was one of the most, or maybe even the most safe place to be during pandemics. Also, Abu Dhabi is the only one city where I saw such phenomenon. When I was first visiting Abu Dhabi, the first thing which I saw is like huge banner, like an enormous big banner where it was written on the entrance to the city, the science of longevity, pure health. Whenever I'm visiting any other cities, I'm seeing a lot of advertisement, but mostly it will be about something like entertainment or maybe even alcohol. At best, it will be about football championship. So many other countries can, probably learn from UAE and Abu Dhabi, on such type of things. On the other thing, what is important, in regards to health longevity on the national scale. Longevity is not only about health tech, not only about medicine, so it's much broader, and the role of government regulators should also kind of consider this matter. For example, here is my banking card. So this is MasterCard, this is fintech application, but at the same time it's longevity banking card. So this is integrated solution between fintech, mobile health application, insurtech, and longevity marketplace. So now, when we are talking about longevity on a national scale, it's about longevity insurtech, pension tech, fintech, wealth tech, and more broadly, longevity financial industry. And I think that UAE, Abu Dhabi, they have all required components, to be able to establish one of the most progressive, most sophisticated, potentially, strategy on national industrial strategy on health longevity.
Thank you,
Dr. Ram, your
Dimitri.
thoughts?
I think if you talk about longevity, there are direct interventions and indirect interventions. Many of the direct interventions are actually at the level of research currently. But if you look at indirect interventions in the UAE, I think one of the biggest interventions, in my opinion, which has taken place is the Riayati unification of electronic health records. This is going to give a database of, everyone who has been a patient. Now, when you use artificial intelligence to analyze this data, the indirect implications on longevity obviously are you're going to identify earlier, you are going to intervene earlier through preventive measures, you may intervene through therapeutic measures. Hopefully that segment will become less. And if you look at artificial intelligence per se, this is the only country in the world which has a Ministry of Artificial Intelligence and a Minister of Artificial Intelligence. Now, this artificial intelligence research or drive is not confined to fintech and other areas. A lot of it is in healthcare. You have almost 20 to 25 healthcare-focused startups who are focusing on indirect aspects of longevity spread across. So you have this artificial intelligence drive, you have this drive to collect patient data and analyze it, and you have measures where we are collecting population data, although there are privacy issues. When you put all this together along with the genetic profiling, the UAE Genome Project, you have genetics, you have data related to the highest non-communicable diseases, you have AI, and if you can democratize this, I think this is one of the countries where there is extreme focus on longevity, because it's all going to finally flow into that.
Absolutely. I'd like to thank our panelists for giving us an idea of how AI is being applied to healthcare right now and giving us a glimpse into the future and the potential uses and outcomes of AI in healthcare in the future. Thank you so much.